Hi everyone, Miss Adams here. I wanted to do a quick presentation to go ahead and review our Unit 5, our energy unit. We were able to get through almost everything in Unit 5 except for the types of energy. So what I'm going to do is we're going to review the things that we learned in Unit 5, and then at the very end I'm going to spend some time talking about the different types of energy. Now Ms. Thomas and I have mentioned those types to you. If you remember, we were talking about chemical energy and mechanical energy, which is potential and kinetic. We were talking about sound energy or radiant solar energy, things like that. That's what I'm talking about. So we'll go ahead and dive into that a little bit more today. But I want to have fun with this. I know that I can't hear you guys when you're watching this, but I left some blanks open for you. I want you to go ahead and shout out the answer when you see a blank, and I'll give you a few seconds to do that. So we'll go ahead and start with the first one. We'll start off easy. Energy is the ability to do what? So I'm going to go ahead and give you 3 seconds. 3, 2, 1. Energy is the ability to do work. All right. The next one, potential energy is blank energy. Kinetic energy is energy in blank. 3, 2, 1. Potential energy is stored energy, and kinetic energy is energy in motion. So some examples of potential energy would be a chair just sitting there or a desk just sitting there. Examples of energy in motion could be cars driving down the freeway or you riding on your bicycle. The law of conservation of energy states what? The law of conservation of energy states that energy cannot be created or destroyed, only transformed or transferred from one form to another. So we gave you a lot of examples of this in class. For example, a car sitting at a red light would be considered potential energy, and as that car starts to take off, that would be potential turning into kinetic. But no energy is created or destroyed during that time. It's just changed from one form to the next. What is the major source of light energy? It's the sun, of course. The sun is our major source of light and heat energy. What kind of energy does a rubber band have? Now, I know with my class, I haven't really mentioned this as much. It was in the lab station in the Organize It section, but a rubber band has something called elastic potential energy. When a rubber band is stretched out and you're just holding it, it has the potential to become kinetic, and rubber bands are elastic. So it has elastic potential energy. An example of potential energy would be, so you're going to go ahead and name anything that's not moving. So the examples that we came up with were a car sitting on top of a hill, a skier on top of a hill. Now we put them on top of a hill because remember, the higher an object is, the more potential energy it has. Also remember, the more mass that an object has, the more potential energy it has. An example of kinetic energy is, I'll go ahead and give you a few seconds to come up with an example on your own. And the examples that we came up with were a child swinging on a swing set or a ball rolling. Those are objects that are in motion. So as I was just saying, the amount of potential energy that an object has depends on its height and mass. Objects with greater weight or objects that are greater in height are considered as having greater potential energy. So, for example, if we have a 150-pound skier on top of a high hill and a 150-pound skier on top of a low hill, the 150-pound skier on top of the high hill is going to have more potential energy. If we have a semi-truck and a motorcycle sitting at a stop sign or a red light, the semi-truck is going to have more potential energy because it's heavier, okay? The amount of kinetic energy that an object has depends on its speed and mass. Objects with larger masses or greater speeds are considered as having more kinetic energy. So if I have a semi-truck and a motorcycle both going 60 miles an hour down the freeway, which one's going to have more kinetic energy? It's going to be the semi because the semi has a lot more mass. And you can think of it like if they're both going 60, which one's going to take longer to stop? It's that semi because it has so much more kinetic energy. Same thing with both of those are sitting at a red light, the semi truck and the motorcycle. Which one's going to take longer to get going again? It's going to be the semi because it has a lot more potential energy. So here's the part that we didn't really get to dive into as much as we wanted to, but we're going to talk about it a little bit now. The different types of energy that we learned about, that we were going to learn about. One of them is thermal. And when you hear the word thermal, I always want you to think of heat. Thermal energy is created from the moving and the colliding molecules. Okay, the hotter substances, the faster the molecules are going to be moving. So for example, which has more? Is it going to be a glass of ice cubes or a pitcher of boiling water? Which one would have more thermal energy? It's going to be the pitcher of boiling water, of course. Okay, it's hot. Anything that is hot is going to have more thermal energy than anything that is cold. Then we talked about, I don't want you to get confused by the word mechanical, but potential and kinetic energy. So we call it mechanical potential and mechanical kinetic, okay? Mechanical kinetic is just moving or in motion. Mechanical potential is stored. Sound energy is produced when an object is made to vibrate, which produces a sound. We have electrical energy. Electrical energy comes from electrons in an atom. We have hydro energy, water power. Remember, in the lab stations that we were talking about the dams, and I was cracking up about the dam doors, and when the dam doors open, we have hydropower, and that's potential energy turning into kinetic energy and spinning the kinetic energy is spinning those turbines, causing us to get hydropower. Some more types of energy are chemical energy. So chemical energy can be anything from gas, coal, batteries, and food. So our bodies use chemical energy. When we eat food, it will turn into chemical energy, which powers us and enables us to have kinetic energy, allows us to move. We have geothermal energy, which is heat from below the Earth's surface. We have biomass energy, which is energy produced from living or once living organisms. Nuclear energy, stored inside atoms, made from fusion or fission. Remember, Miss Thomas and I were telling you about we talked about nuclear fusion in the beginning of the year when we were talking about the sun and how the sun makes its energy. Nuclear fission is the opposite. So instead of the atoms coming together, they are separating. Then we also have radiant or solar power, which is energy that comes from the movement of light or the sun. And then gravitational energy, the energy that pulls us down. Gravitational energy is the reason why it's easier for you to ride your bike down a hill than it is up a hill. So this is just the last little thing. I wanted you to see how energy can change. So the first one, we have solar energy, and that solar energy is sent down and hits those solar panels, and that solar energy can turn into electrical energy, which are those power lines, and that electrical energy can turn into light energy in our homes, or heat energy, or sound energy if we have our radio on. So that's just an example of how energy can be transformed or transferred from one form to another. But again, remember, it's not created or destroyed. So I think that's it. Yep, that's the last slide. We don't know exactly what's going on. As far as we know right now, we'll be returning to school in a few short weeks. But up until then, Ms. Thomas and I are still expecting that you're getting your work done. Packets will be home to you soon if they haven't been. Keep trying to come onto Google Classroom, checking for all your classes. Your teachers are on there daily. And of course, if you have any questions, please ask them. You guys are doing a great job. Keep up the great work. Get your friends to join in. Now, here is a quick bonus question to make sure that you listen to the entire thing. I want you to, below this post, tell me the definition of energy, and then also give me an example of potential energy and kinetic energy. So below this post, go ahead and tell me the definition of energy, and then give me an example of potential and kinetic energy. Okay? And that was just your little exit ticket or your quiz to make sure that you're listening. All right, we will be talking to you guys very soon. Stay safe. We miss you very much. Talk to you later. Bye.